everyone, how are we doing? We can actually have some music now. How are you doing, Cameron? Let me see how. We should have the music and everything. So we should be chill now. Music sound good right there? I might actually lower it a little bit. And it's kind of loud for me. Oh my gosh, is this what it sounds like for everybody? Doing well? Awesome. We got the new PC, and I can actually hear the music now. Look at this. There we go. Lowering the volumes to nice. I know it's a little nicer outside these days. Okay, I should set these all to like 29. Back through these. Okay, there we go. Better music, better sounds. I have to fix Mubot first, and then we'll get started on some work. I have to be on a live stream to see if Mubot's working. Does he still have everything in his brain? Okay, I just re-downloaded Mubot via the site. There's no way this would work right now. Let's see. Streamlabs plus chatbot installer. So, better pizza. I said, we got to get Mubot working again. What happens if I run this? Well, let's find out. Should have exported. Oh, he's not going to have all his settings. I accept. Okay, we're installing it here. And so it's in roaming Streamlabs chatbot. Let me take a screenshot of this. And then what I can probably do is I can copy over the information from the other one because we have a new PC. Create a desktop shortcut. We like that. Okay. I hope we can. Does it look better? How's the video look? How's the audio sound? What are the new specs? Oh my gosh. I should put Specky on here and show you. It's like 24 core. I think it's 24 core. It's a, where do you go on your PC? Oh, Setup Wizard. Start. YouTube. Man. It's 24 core, I think. Pretty crazy. It is pretty crazy. Skip the Setup Wizard. You want to skip it. And it's, what else does it have? It has, I think, a 4070 in it. I used to have a thing about, I'm about the AMD Ryzen life. I think it is, please authorize your Streamlabs connection to V2 or API with a new offlow. If you're done, you can ignore this. You know, we're going to try and break this. Mubot exists now on this computer, but it doesn't really exist. I'll show you over here on the main screen. So let me copy the, okay, you can hear me here. This is the Go XLR. And so we should see Go XLR on this. There's the Go XLR. Okay. And let's go to this screen. And now you should be able to hear me on this screen. Good, you can hear me now, right? Thank you, Cameron. That's why we're setting up the PC again, kind of. I did a lot of work on Friday, copying over files. So it's been a lot, like we've been left and right and up and down. But it might be, let's see if we've got audio here. Now we have audio over here. I also can't delete myself off the screen. Let me fix that. That's an easy fix. All these things. I worked on this for like 4 hours on Friday. There's so many things like to know how to do. This is MuBot right here. Good. The Zoom still works. So this is MuBot's brain, and I think I can get it working in just a second, then we can start on some actual work. But this is MuBot's brain right here. So I'm going to copy over the stuff from MuBot, and we'll try to get that working right here. What assignments are you guys working on? Got some chill music now. We're getting everything working. I had to disassemble a whole studio, a whole Texas studio. So everything was set perfectly, and now it's kind of ripped everything apart. So we're almost back to normal after 3 weeks or so. But yeah. What are you doing, William? What are you doing, Cameron? What are you working on? Wow, we're working out. Homework 3 has me lost. I know we just started the chapter. Yeah, let's go look. Let's complete all of homework 3 right after this. Let's see if I can get MuBot going. I'm going to set a 5-minute timer max. And so I've got timers going here. 5 minutes going. And if I can't get MuBot fixed by then, we're just going to say, well, we're going 1 day without MuBot. And maybe I'll throw some points or something. Like I'll put a bonus quiz and put some points. Okay, let's try to get MuBot working. Okay, I need to go to the files on the computer. Need to go over to the old PC. It's so far away. Let me bring it over to this screen over here so I can see it closer. So we're going to start homework 3 right after this. Going to the old PC. Going to, what was it? I saved the snip of what it looked like. I was users app data roaming. The users app data roaming. Might have been elsewhere. Streamlabs. Which parts on homework 3? There's a lot of conditional and marginal distributions. I'm gonna fix my contact right there. Conditional distributions, marginal distributions, all that good stuff is chapter 3. Chapter 3 is a fun one. MuBot, where are you? We're gonna like literally copy over the parts of Streamlabs back into it. The second question, oh, we'll have that here soon. Wait. Oh my gosh, I found it. Totally found it. Streamlabs roaming. I literally think we're just gonna copy this. Let's see what happens if we just copy into it. You ready? Okay, so let's go. Let's disable this MuBot. Disable this MuBot. He's disabled. We don't like that MuBot. And then we are going to try to overwrite into the brain of it under this one, this computer here. So now we're going to another computer. We got old PCs in here. I've got my old laptop in here, my old desktop. And so now we need to on this computer. So we'll get started. We've just got a minute or 2 left to try to do this. Okay, C drive, I think C drive, users, B Stevens, that's me. Roaming, what was it called? B Stevens app data. App data, roaming. And I think this is where we copied everything from. Oh, and then we need to go into Streamlabs. There we go. Okay. And then, oh, I think we're in Chatbot. Okay. I'm gonna ask, I want to overwrite a bit. Replace the file in this destination. Good. Okay, we just overwrote everything in MuBot. And so now we need to go back to the desktop and cross your fingers. We're going to pin this to the taskbar. You don't want to pin to start, pin to taskbar. Here, let's run it and then let's pin it. Okay. It's either going to crash or it worked. Because I just copied all the files. It's loading at least. It didn't say like error can't load. Here's the answer. It's taking a little longer, so that's good. Okay. He's here. We did it. That's something I had to do when we were online to see if it worked. So MuBot is here. MuBot is working. We copied over MuBot. I literally went and saw where the files were at. So I had to go and get the chatbot right there from all that, copy over the files, all that good stuff. William, let's make you a mod and let's start some chapter 3 right here. So we fixed MuBot. 10 minutes in or so, we fixed MuBot. We're making William a mod. And let's go and do this right here. One of these days, I'm going to go to an eye doctor and get my eyes fixed up. I seriously might go and do that LASIK surgery. W for William right there. Let's throw some 100 points. Can you check your points too? See if Mubot still has your points. He's still able to give out points, so that's good. Mubot's still giving out points. We like that right there. We don't have the points sound effect anymore. I got to copy that back over. And we're going to see if points still exist. You still have your points. Yes! Oh man, this is a whole new PC build right here. So we are good to go. And let's get my Pearson going. So we still have our points. People are still leveling up. So many levels. Brian tier and Vol for Life tier, VFL. So remind me later. I'm logging into my Pearson currently. We're going to do Chapter 3 homework. We can get that done nice and easy, and you'll get to see how to do it. I think I know my password. There we go. We're getting logged in. Brian tier. I know, right? Well, there's the bell. We did it in under 5 minutes. All these, thank you everyone for like people not being like, oh, why are things not set up? Why are things not working? Rip took down a whole studio that had been teaching from for 3 years, and then we basically like right before the semester started, like I think it was like 2 days before it started, we got everything into this room. So I'm really lucky that, you know, we were able to do this. It's huge thank you to Haslam. Okay, so we're doing the whole homework. Have your homework open. Let me put it in the notes right here. I'm gonna pause that in the background. And where is the edit video? Here we go. Random question, do you know what happened to the stock market thing in Haslam? Oh, well that was the Bloomberg terminals. I don't know where they moved them to. Dr. Laura Cole, amazing teacher here in Haslam. She might be one to know because I think she was over the Bloomberg terminals. I noticed they were gone too when I came back. And I mean, I missed them. They're really cool. Always like seeing those Bloomberg terminals and seeing what people are doing. So there are some tricky questions on this. Remember, start early on these because these are not the easiest of questions. Okay, let's go do it. Okay, so we are going to get started on the homework here. We're going to mark the stream right here. This is 1433, Chapter 3 homework. Okay. Mubot loving some randomness. If you say randomness, Mubot kind of goes crazy. I can finally hear things again. So the first question reads, a research group asked 2,152 U.S. adults and 1,046 college presidents to rate the job the higher education system is doing in providing value for the money, with families rating from excellent, good, only, fair, poor. Now, you have to be very careful on what this is asking, and let's think about this. If you are a U.S. adult or president of a college, that is a what question? Just think about the question right here. I want to highlight some stuff for this. If we go and look at this question right here, what kind of data are we working with? I want to know what kind of data are we working with first, because these are the things to review. What kind of data are we working with? Almost got the pen working 100% too. That'll be a good day. What kind of data are we working with? Like, over here, that's a what? That is a what? Categorical. This is bivariate categorical data. Does that make sense? If you're watching, it's 2 categorical variables. How do you rate it? And what is your position, U.S. adult or president of a college? So it's bivariate categorical data right here. So with it being bivariate categorical data, then we can do things like conditional distributions, like what % of people who think it has a poor value are presidents. So you can do that. Or what % of people who are U.S. adults think it has a poor value. So that is a conditional. A marginal, we're not given the marginal, which is a bummer, would be the sum of these values if you were to add them up here on the margins. That's a marginal distribution in the margins. So you've got marginal distributions, which show you the distribution of one variable, where conditional looks within one variable, like of the people who rated it excellent, what % are U.S. adults? And you would add up the numbers here and then put this in the top number if you are doing that question. So that would be what % of people who rated it excellent are U.S. adults, and that's called a conditional distribution. So make sure you have notes on marginal distribution and conditional distribution, and this is what is known as a contingency table. So that's a contingency table. It is a bivariate display of categorical data. What % of college presidents think the higher education system has a poor value? So we go here to college presidents, and then we add up. So let's go ahead and get the calculator. Remember, it's not about finding the answer, it's about knowing how to find the answer. So write down the notes as we talk about this, because we're just going to take these values, add them up right here, and this is the sum of that row to find out how many U.S. presidents, or how many, not U.S. presidents, how many college presidents there are, 1,046. And then we're saying what percent of college presidents think it's a poor value. Man, imagine going to a college president and being like, do you think it's a poor value to go to college? And they're like, yes. And you'd be like, whoa, wow, no, I think it's an amazing value, especially here at the Haslam College of Business. So we now have the percent of college presidents who think it is a poor value, and it's about 2.5%. Now be careful when putting these in because it wants it as a percent. So we're gonna have to change this right here, move the decimals, and it says round to 1 decimal. And so it's gonna be that right there. So just round it properly. Notice it's a percent and round it to 1 decimal. What percent of US adults think the value provided is either good or excellent? What is the comparable percentage of college presidents? So the first thing we need to do is find the US adults who think it's good or excellent. So we're going to do the same thing we just did earlier, but it's only going to be adults, and it's going to be good or excellent. I need to make this a little bit thinner so we can actually just highlight that. There we go. And good or excellent is going to be this group right here. There's good or excellent. Let's bring back up. I still have the calculator up. And so now we just add up the values. 319 plus 894 plus 749 plus 117. Tell me if I make any errors, Cameron. Cameron, so this one's not that bad, right? And that's the total amount. I added up the full roll, find out how many US adults there are. And then we go here and we add up 749, because this is the sum of people who think it's good or excellent. And then we divide that by the total we just found. So that is those two numbers added up in the black circle divided by the total. And that's a conditional distribution. Given someone's a US adult, what is the probability to think it's good or excellent? So 40.2 right there is the answer to that question, 40.2. And let's go look at the next one. And they're going to try to see if there is some sort of relationship right here, because when you look at different conditional distributions, you could see this makes sense. Part B, question 2, ooh, we'll get to that here in a second. So let's do the next one where we're doing the US presidents, and we'll be that question here real soon. Presidents, or I keep saying US presidents, college presidents. The pen cuts out every few seconds. I hate that. I'm going to stop saying that. And let me make sure this is question 1. And calculator. So we go here and we add up the values again. We should have wrote that down, written it down. It's easy to make a math error, but you get multiple tries on these. That's the sum of the row. Now we take and do 613 plus 184. It's also easy to make just random errors. 76.2, move the decimals. Oh, that's the screenshot. 76.2. Here we go, 76.2. Some of the rows in the top, yep. Oh, is that going to be the next one? I don't know. This is the end of this question. Compare the distributions. Now notice, this is where we get into, is there a relationship? Given someone is a president of a college, they would be more likely to think it's a better value. So that's where we think there's a relationship, and that's kind of the point of this chapter, is to say, is there a relationship between what people think the quality of college is, and if they're a US adult or president of a college. And I would say because the differences are so different, college presidents have a better opinion, and there looks to be a relationship right here. Thank you, Mubot, for telling people to tag me. Is it reasonable to include that 5.44% of all US adults think that higher education system provides an excellent value? So this is a weird one. If you go and look at this, I think if you divide the numbers, 117, here we'll just pop it here on the screen. I think you get that, and I don't like the way they word this. So this is one of those questions that is not maybe the perfect question, because I remember doing this from previous semesters. So we're adding up the values again for US adults. And so is it reasonable to believe that? Would somebody be crazy to believe that? There's the sum of US adults. Now 117 divided by that, and we get 5.44. So the sample is likely representative, so the true value may be close to it, but not exactly. But this is only an estimate. That sounds right to me. The percent 5.44 is significantly different than the sample? No. The sample is representative of the population, therefore exactly, we would never say exactly, hey Griffin, good to see you here, doing well. The sample is probably not representative. We have no reason to believe it's not representative. Actually, fair question that I remember. Don't know how I got that wrong previous years. Thank you, Griffin, throwing some points. Now we get to the next one. This is a good one right here. We are now doing the conditional distribution, but I think this one throws you a curveball. So it says, rate the job the higher education system is doing in providing the value of money spent. So the first one is just going to be the sum of the row dividing each number by that. Does that make sense, Cameron, right here? So for the first one, we're just going to add up all the values across the top row and then divide each value by that. And you should get 100%. I think I know where the curveball is going to come into play for the next one because they ask for a kind of weird thing. So we need to find the sum of the top row, 319 plus 901. And Cameron, if you want to find any of these, you're more than welcome to check my work. I'll throw you some points. Just speeds up the process. 2,000. Oh, look, it tells you 2,142 up there, so we could have used that. 319 divided by this, that's 14.9. Oh my gosh. 14.9. And I should keep my taskbar on the button, though I can find that. 901 divided by the grand total, 42.1. Now, you might not get 100% because sometimes numbers round up or down a little bit oddly. So if you don't get exactly 100%, not the end of the world. You know what I might do? I'm gonna take this window and I'll make it a little smaller. Watch this. Whenever we want to bring the calculator back, I'm going to put this window and I'm going to put this right over here. We mirror the calculators right there on the corner. And that's going to make my life easier right there. So now we can get to it a lot quicker. We can just click over here. And now we go and take 746 divided by grand total, 34.8. And then we take 110 divided by grand total, 5.1. We hope for no math errors. And 66, which is going to be about 2.7 or so, 3.1. That was a little off. As long as we didn't do any math errors, we should be good. And now the next one, I think, what did I do wrong? 20, the second one, isn't the second one 20 point? This one doesn't look like 20. Which one did I get wrong here? Round to one decimal. Shouldn't we take the... Well, all B. There you go. I did US adults. That's how you do it. That's how you make an error. 27. I was just seeing if people were paying attention. Let's throw 100 points right there. Just checking to see if you're paying attention. I just did all the US adults. So wrong totals. Wrong. I did the wrong conditional distribution. That was the conditional of US adults. We were meant to do the conditional of presidents, not of US adults. So 214 divided by 1036. 1036 is the total of presidents. And as Cameron said right there, that's 20.6. Keep checking my numbers because I am capable of errors. Or is that it's going to round up to 20.7. And then 59.5 for the next one we're saying. Thank you so much. Throw you another 100 points right there. Keep getting those points. This should be like 18 point something or 17 point something. 17 or 18 point something. I'm kind of going off the estimates there of it. So it should be, what is the next one? I can find out too. 17.3. Nice. And then the last one is going to be 0, right? Because no one responded this. So let's hope it's not a second time we make an error, but it's not. Once again, just the top row. Now, this is where it gets interesting. This is where it gets interesting. It gets a little tricky. Find the conditional distribution of the opinions of US adults when the categories are combined into negative is poor, middle is only fair, and good or excellent. Now, this is where it gets interesting because we're looking at of the people. Let's look at this. Here we go over and let's go to a Word document. Where it gets tricky. We have to take, and I believe we have this group, this group, this group, this group's gone. So there was 66 people over there behind my head. 66 is the number if you didn't get to see it. There it is, it's 66 and it's gone. So remember from the problem, there was a total of 2,142 US adults. So if we go back to the Word document over here, we need to take and find the new grand total, and the new grand total is is going to be 2,142 minus 66. Does that make sense, Cameron, right there? And also William. Does that make sense? We subtracted off the 66 out of the total. We have 2,076. So the new total over here is 2,076. That is the new total. So now what will we do? Well, this one over here is 856. 856 because that's the sum of the two groups. So what should we do now? Take all these numbers and what? You see kind of the work we need to do. We're going to do the same sort of work right here. And we're going to take the numbers, put these in the chat here so we can remember them. Let me see if I can get it on the screen at the same time. I'll just zoom out a little bit on this. Oh, really? There we go. The first number here is 319 divided by 2076. So the first number is 15.4. Drop that in the chat real quick. 15.4, 901 divided by 2076. And that's 43.4. Oh no. Oh no. No one's dropping in the chat yet. Oh no. We're going to lose the numbers here. I'll drop it in the chat. Was it 15.4 and 43.4? Those are the numbers. Easier to keep track that way, and then I can write it. And then 856 divided by 2076. And that's 40, thank you so much, 41, maybe I'm on a delay today, 41.2, all the numbers in the chat. Okay, so that adds up to 100%. We should be good on this now. We should have all the values. And let me mark kind of where that second question was at in the stream. We got to it about 21:33 in chapter 3. Homework. Question 2. Check time on it. And so now we go over here and we start dropping in the values on it. So here's the negative, which is the poor, and that's 15.4. And then middle is 43.3. I think the most people were there. And then the excellent was 41.2. So as long as we added them up properly, we're good to go. And that's got it. Is that the end of this question? It might be. That's got it. Is it looking a little bit better? Question 2 is done now. That one just wanted you to add up categories and subtract off the group it wasn't using. So a little tricky. That is kind of, I don't think we've written a test question like that. A little tricky on that one, but once you see that it's like only use these groups, you just kind of subtract that other one out of the total because they're not part of the consideration of questions answered. Yeah, it's kind of odd. It's like why did they remove out that group? Someone could just say that people who didn't answer, we just removed. Like people said, I don't know, because the last group was like, I don't know, did not answer. So we just removed them out of the total of people who were considered as part of the answer. So kind of all right. I think it's odd to do it too, but like I'd say, this percent of people said, I don't know. So I would have reported that way rather than what they did and delete them off. Kind of weird. We usually don't just remove data. Okay, so here's the next question. 299 undergraduate students are asked about their diet preference, carnivore, omnivore, vegetarian, and political alignment. A stacked bar chart of 285 responses are given. I guess people didn't answer. Describe what this plot shows using the concept of a conditional distribution. So given someone is a carnivore, does that make sense? Because this is only carnivores, they are more likely to be what? Yeah, maybe that makes sense. I don't know. And I see that there's a lot but think about what color goes away as you go from carnivore to vegetarian. Given someone is a carnivore, that's how conditional distributions are stated. Like, given someone is in this group, here's what we see for the other variable. So given someone is a carnivore, that's a conditional way to talk. Like, oh, given you are a carnivore, now you're actually still have a high probability of liberal, but conservative goes away as you go towards vegetarian. So maybe they did this in like New York or California where there's more liberal people. We're not getting into politics, but we all know California is more liberal, Texas is more conservative. So we have right here, given someone is a carnivore, they are more likely. It's kind of half and half-ish, and it's kind of even third. Then when you go to vegetarian, vegetarians are predominantly liberal, according to this graphic. So remember how to talk about conditional distributions. That's what this question is teaching you. So what does the plot show? So vegetarians tend to be more conservative than those with other dietary preferences. No, vegetarians tend to lean more liberal, and that's what we see right there. Remember, this is conditional on given someone is a vegetarian, they tend to be more liberal, and that's what the graphic's shown. Given someone is a vegetarian, it's the important way to look at it. The differences are probably, and here's the thing, if you were to see that it's flat across, then...
Notation, brother.
Oh no, can I not hear this?
It doesn't matter!
Oh no. Did you guys hear the "it doesn't matter"? Routing. Did you hear "it doesn't matter"? Why can I not hear that? Oh, my sound effects aren't in here, I bet. Oh, you did? It doesn't matter. Why don't I hear that? Well, everything's fixed except for me hearing my sound effects. We'll worry about that here in a little bit. Maybe I'll try to do it after we do the homework. The second one was, yeah, there's the "it doesn't matter." And then here's the "it matters." So if it's flat across, the differences don't matter. The bigger the differences in the conditional, the bigger it matters. So you'll notice right here there are some gaps that look to be kind of biggish, where at the end you see there's no vegetarians who are conservative. So I'd say there looks to be some sort of relationship here because the conditional distributions have a pretty big difference. That's the way to talk about it. The differences are probably not likely by random chance or significant. Real, that means not likely by random chance. Diet preferences and political alignment appear to be associated, have a relationship. We would not say correlated, so strongly associated is not independent. Independent means no relationship. Strongly associated means a relationship. So that's how we would talk about that right there. Gets into some bigger topics we'll do later in the semester. Finally, we get to a mosaic plot. A mosaic plot is the visualization of bivariate categorical data. You can see the mosaic plot behind me right here. So here's the mosaic plot in the corner. Now it won't delete me off the screen. We'll worry about that here in a little bit. I don't like those. No, they're so good. They're so good, Cameron. We'll throw you some points for not liking mosaic plots. They're so good, though. About blank % of men in the survey were diagnosed with prostate cancer. Great, great happy times. So this one right here is pretty interesting because the mosaic plot actually shows you, is it making new snips every time I do this and like keeping them on the screen? I don't like the new snipping tool. So let's bring this over here. And what you want to do, this one is very, very generous. I've taken more time to do this one than I'm going to do here. But the bottom of the graphic is a margin. Notice this down here is a margin. So a mosaic plot in the margins, I hope so. So more men did not have prostate cancer than did have prostate cancer. And then you can see the conditional is the within. So this is a conditional right here, and this is a conditional. Given someone had prostate cancer, what % of fish did they eat? Given someone did not have prostate cancer, what % of fish was in their diet? Does that make sense? So it's looking within the variable prostate cancer, yes, prostate cancer, no. Those are conditional, but on the bottom, it's a margin, so you can see what % of men got prostate cancer. Now, what's really nice, look at this. This is about a what ratio. Like if I said, this is like, would I say this is 100-to-1 ratio? Does that look like that's 100 times bigger than that one? What do you think the ratio is? Like, that one's this much bigger. Like the length of this over here, just take a guess and I'll show you how nice of a window they give you on this. So the length of this compared to the length of that one. Like the length on the left is about how much bigger? I wouldn't say it's 100-to-1. I wouldn't say that's 100 times longer. That's ridiculous. I'd say, it's about how many times longer? How many times longer do you think? Oh, we're on Top Chat. That's why it's taken a moment. That live chat. No, well, like, think about this. If I were to copy this, which I've done before, this right here, you see this little thing? Like, is it 90 times that distance? 10 through 15? 10 through 15 is probably a good guess right there. Let's go with 12. Does that make sense? So we're thinking this is like a 12-to-1 ratio. Does that make sense? Like, this is a unit, this is like 12 inches, and this is 1 inch. Does that make sense? 12 inches, this is, 1 inch, that is. Does that make sense? So yeah, exactly. So how would we figure out if that's 12 inches and that's 1 inch, then what % of the bar is this? What % of the total is that? So do the math and think if that's 12 and that's 1, then the one that is 1 is what out of the total? So you'd be like, oh, that's out this % of men now. Use the numbers there, and I think we'll get it right because it's pretty forgiving on the interval. So what do you think? If that's 1 out of 12, or like the thing is 12 and this is 1, then mathematically the thing that is 1 would be mathematically how much? So think about what you would do with those numbers to figure out the ratios. 1 what? 1 divided by, maybe you said 12, but not 12. It'll probably still give you the right answer. 1 divided by 13. Does that make sense? Because it's like there's 12 units here, there's 1 unit here. So this is 1 out of 13 total units. Does that make sense? I'll show it again on the screen and I'll say the same things. That's about 7%. Type in a whole number, 7%, and you get it right. It's a very forgiving guesstimate answer. But I'll show that again right here to show you how we guesstimated it. About 7-ish% exactly. So because we think that this is like a 1 to 12 ratio, it's very, I think it gives you from like 5 to 12 or something. It's a very big window of the numbers. But if you kind of guesstimate, like you wouldn't think that's like 20% of the data. It looks somewhere to 5 to 10% of the data. So how much of the data goes across the bottom right here? I think 7% is very, very close to the right answer. So good job right there. There are more men who blank and never seldom eat fish. I forgot to put the timestamp again. There are more men who blank. So what does it say? Are there more men who had cancer and never seldom eat fish? Or are there more men who did not have cancer and never seldom ate fish? Okay. Here's the, okay. Oof. So are there more men? That's just a quantity who had cancer and never seldom ate fish. Never seldom is this yellow, this white bar right here. Now this is going to sound crazy, but imagine these are bars of gold. Would you want this bar of gold right here, this gray one, or this one? So are you looking at the no or the yes? Do you see this right here? Do you want the no bar or the yes bar? You want more gold because we want to know how many there are. The amount of area it takes up is how many there are there. So do you want the no bar or the yes bar? Which of those is a bigger bar of gold? Now the yes bar is a little bit wider, but it's not nearly as long. The no, it's interesting, you actually want the no bar. Remember, this is 12 times longer than this one. This one's maybe only twice as thick. Does that make sense? But is that, I might have made it confusing. So the amount of men in this group is how big of an area it takes up. Does that make sense, Cameron? So the amount of area that that gray bar takes up is the amount of men in that group. So the gray bar in the no takes up more area than the gray bar in the yes. Even though the gray bar in the yes is a little bit bigger, that would mean a greater proportion for that group, but the amount of men is the total area. So you have to read it very specifically. It says, were there more men, meaning total. Does that make sense? So it would be the no group. So all you're looking at, here, I'll give you an easy one. You ready? Are there more men with a moderate part, were there more men with a moderate fish diet who had cancer or did not have cancer? Were there more men with a moderate, which is blue, who had cancer or did not have cancer? Were there more? Is it the no group or the yes group here? Were there more men who had cancer, moderate part diet, or not had cancer, moderate part diet? Is it no or yes there? And here's what to look at. Notice right here that this blue area is huge and this blue area is tiny. Does that make sense? So there were more people here. Don't look at the conditional yet. We're just saying, are there more people here or are there more here? We're just looking at the area it takes up. So now with the gray one, is the gray no bigger? Like area-wise, not height-wise. Don't look at height, just total area. So is the gray no bigger or the gray yes bigger? Now remember, the gray yes is about twice as high, but this one's 12 times as long. So for this one, the no is bigger. Does that make sense? Like if this was a bar of gold, you could melt it down into a bigger thing. It would be a bigger thing. Like, don't worry about that it's like thinner. Yeah, does that make sense? Yeah, it's a little confusing. It's the area it takes up for the amount of people in the group. The area is the amount of people in the group, where the marginal will be the percent within that group. So it is true that this has a higher percent within the group. This has a lower percent within the group, the gray bar, but there's more people in that gray bar. So it's asking a very specific thing right here, and it probably talks about the area. There are more men in the did not have cancer group. Watch me get it wrong now. And then they might mention, I think they do a follow-up. So now, which is higher, the percent of men who with cancer who never seldom ate fish, or the percent of men without cancer who never seldom. So now this is what you were talking about, Cameron, right here, because now if you look at the percent right here, this is a higher percent in the yes group. Does that make sense? The yes group has a higher percent because it's higher. There's a more height to this. So within the yes, there are more individuals here percentage-wise within the yes versus within the no. So that is the question that we just did right here. Which is higher, the percent with cancer who never seldom ate fish? This is a conditional. So this is with cancer right there. That's a good one. This is a good one. 2 more questions. We'll be done with the homework. It's a good homework. Lots of practice on conditional, marginal, all that good stuff right here. So I want to tell people, show up to class before at the office hours, get the homework done. The Pew Research asked the same amount of adults and same amount of college presidents rate the job. Let's go take a look at the plots right here and see what we got. Woo! So now we got a mosaic plot. And what you can tell right here is there's very differing opinions. Did they talk to more US adults or more college presidents? So we're doing a review of the concepts right now. Did they talk to more US adults or more college presidents? This is a review of the concepts. Did they talk to more US adults or more college presidents? And where do we see that? More US adults. It's about a 1-to-3 ratio or 1-to-2 ratio. And you can actually tell that from the question where they say about 2,000 to 1,000. Great job, Reagan. Let's raise some points for being here. This is a marginal distribution. Notice how it's in the margins. Does that make sense? You're down here in the margins. So the margin shows one variable. We're not looking at their thoughts. We're looking just at the marginal distribution, which shows one variable at a time. Were they adults or presidents? What group are they in? And presidents are more likely to have an excellent rating and a good rating versus adults are more likely to have a poor or do not know rating. So we do see some sort of an association right here due to the large gaps in the conditional distribution. About what percent were college presidents? I think this is nice. You can see it's about a 1-to-2 ratio. So we're going to go here and type something like 33, see if it gives us the answer. And it does say nice work. If you do want to find the right answer perfectly, to find the exact answer, you'd find the total amount of people spoken to. Here's the total amount of individuals spoken to. And then we divide the amount of US college presidents. And so it's 33 almost on the dot. Like I said, it's about a 1/3 right there. From the mosaic plot, it's easy to see if there are more US adults who said college provides excellent value or more presidents who said excellent value. Yes, because the area, not the area. The area is the amount of individuals in the group. We want to look at the height within the conditional again. So just to review, the amount of individuals is going to be how big it is, like area-wise. There's a lot of presidents in the good right there, but also it takes up a height, which means a higher percentage of presidents, which is a conditional idea. So the height within one of the groups is a conditional distribution, like given someone is a college president, what's the probability they think it's a good value? About 70%, 65%, because that takes up 65% of the height. Do you like these a little bit more, Cameron? Maybe, because now you can compare like about twice the percent of college presidents, because look at the height of the adults bar versus the height of the college presidents bar. College presidents are about 2 times more likely to think it's a good value, and maybe kind of-ish. Maybe we'll win you over by the end of class. We'll start with a review on this. So yes, because the proportion within each rectangle is vastly different. And that's what's gonna, oh no! Is it easy to see? Oh, more, it didn't say percentage. It just wants to know more. It just wants to know, are there more people? So more people, not percentage. Wait, what? Oh, I had to get one wrong. It must have been that it was having us to compare 2 rectangles that were about similar in area. So is it saying which one? People who said it's an excellent value. Oh, they want to know how many. So they're asking, is the area of the purple rectangle bigger than the area of this purple rectangle? And they're different heights and widths, so they're very similar. I can tell that there's a lot of, it's easy to see that there's less presidents that think only fair, but it's saying that the purple rectangles are hard to compare for total area, because that's how many people are in there. Does that make sense? The purple rectangles are hard to compare for total area because that's how many people are in each group. I should have looked at the rectangles and saw if they were easy or not easy to compare, because the amount of people is the area of the rectangle. So, we have to get one wrong. I'll show you again how to redo the question and we'll get it right here. Is it easier to see the percentage of college presidents who said it's an excellent value? Now, yes, the percentage is going to be a what distribution? Comparing presidents and adults is comparing the what distribution, say that word again, and then we'll get it right. So if I say, is it easy to see that more presidents think it's a better rating versus a higher percentage or lower percentage of adults think it's an excellent rating? We're comparing the what distribution starts with a C. To say, let's compare the percent of presidents who think it's an excellent rating or an excellent value versus the percent of adults who think it's an excellent value. Conditional, Cameron, with those 100 points right there. Conditional, and Reagan, great work. So now we're doing a conditional distribution right here. Yes, because the proportion is easy to compare right there. So there we got that one. One last one from the mosaic plot. Do you think there's an association? An association exists when the distributions have large gaps in the conditional. So let's say right here, yes, because they're very different, and that's the conditional distributions are very different. If you ever get a question wrong right here, you can go back and do, it'll just restart it for you apparently, or you can click similar question, your highest question is taken. The questions on the homework especially don't vary up much. So if you do get something wrong, you can go back in here. No, because it's not easy to compare those two rectangles, those specific ones. Yes, because the proportions are different. And down here, yes, because they are very different. I wouldn't suggest doing the homeworks this way. Can you explain more about associations? Yeah, let's do that right after this one. Thank you, Reagan. We got more than enough time right here. We're going to talk more about associations right after this, and I'll show you how to see bigger associations, and I'll even break into some stats concepts, which will help for later in the semester. Reagan, another 100 points. Thank you for asking me to go more in depth on that topic, because it's a big one. Chapter 3, homework, question 6. So we'll finish off the homework and then do that question. We've got 299 students asked about their diet and political alignment. Are there more men or women in the survey? Now, how many variables are we talking about here? Are there more men or women in the survey? How many variables are we talking about? We're just asking men or women. Are there more men or women? How many variables is that? It's only one. Because you're saying to someone, what is your gender? Does that make sense? William, good guess right there, 100 points. We're asking one variable and it has like 2 levels or 2 answers. Does that make sense right there? It's just, what's your gender? So that's the variable we collected on, and let's go look at it in the marginal distribution. So in the margin, you'll see down here, and they kind of did it weirdly. They're saying, are there more men or women? And I think it's clear to see the what group is bigger for each one of these. The what group is bigger for each one of these. The what group is bigger for each one of these. And then they did like a within. Which group is bigger for each one of these? The male group is bigger. There's more width on the bottom. So you can see there's more men in the survey, and then they even broke it down with a third variable like liberal female, liberal male. Looks like males they have more red maybe at each time. It's kind of hard to tell. This mosaic plot, I agree with you, Cameron. I don't like this one that much. There's other ways to do a multivariate mosaic plot, but I wouldn't do it the way they did it. So there are more men because the conditional width bar is labeled, width bar is labeled M. The total area of the bar is labeled M is larger. That would be it right there. The total area on the bottom right there. So that sounds good to me. Does there appear to be an association between politics and gender? Okay, let's look right here. Liberals are more likely to be what? Liberals are more likely to be what? So look, are there more liberal males or more liberal females? More liberal males or more liberal females? Are there more liberal males? Is that bar bigger for males or more liberal females? We're just looking at only liberals. Kind of an odd comparison to do right here. So are there more liberal males? There's more liberal males. There's more moderate males. There's more moderate male conservatives than female conservatives. At all point, males outnumber females in this survey. Is the ratio the same? It's kind of hard to tell. It doesn't look to be that big of an association. There appears to be a weak, hard to say anything, association between politics and gender, because the relative proportion of females in each group for politics tends to be become smaller. So this is where I'm iffy on this, because if we're saying it becomes smaller, that's evidence of an association. This strong, I wouldn't say it's strong. If they say it's strong, it would be a little bit, let's see. There's something, because the female group doesn't become larger, it becomes smaller. And what we're talking about here is look at the width of the female comparative to male. It's like a 1:3 ratio, a 2:1 ratio, and a 1 to 1.5 ratio. Is that strong? Are they going to call that strong? They are calling that strong. So you get to see some of the answers right here. I would have said moderate, maybe. Yeah. I was thinking they were going to go strong on that. So I was like, is it strong? Really? Really? That's strong? We'll talk more about it here in a second. People want to go over what do relationships look like. But there's something going on. How strong is it? We can run a statistical test to figure that out. Let's look at the next one. Does there appear to be an association between politics and diet? This is the easy one. So notice here, as people become more conservative, they are more likely to what? As people become more conservative, they are way more likely to become what? Especially conservative males. Even conservative females would be blank more likely, 3 times more likely than liberal females. So as people become conservative, they are way more likely to eat meat. So there we go right there. Does McDonald's count? Because I just ate some sausage McMuffins this morning. I'm going to say strong. Watch it say it's weak. I think it's moderate-ish again. So it's on that iffy range. We would be fine if you said there is an association. Because between politics and diet, because the conditional distribution leans towards as they become more conservative. Includes more meat as they become more conservative, and that is correct. The difference in the proportion of vegetarians between liberals and conservatives. So vegetarians are, conservatives don't have any vegetarians over here. So when you go to the conservative group, males and females, no vegetarians versus the liberal group, there's a lot more, is very different. The difference in the proportion of vegetarians between liberals and conservatives is about the same for men and women. The difference in the proportion of carnivores, such a complex question with 3 variables. The difference in the proportion of vegetarians between liberals and conservatives. Oh, they're looking right here. Liberals and conservatives. Well, conservatives... The difference in the proportion of carnivores between liberals and conservatives is carnivores, there's way more carnivore males. 2, larger for men. It might be larger for female because there's a bigger dip for females. So I think that's what they're getting at. Let me show you again what they're talking about. Notice how when females go from liberal to conservative, they lose 20 or 18%. So notice we're saying the drop, I wish they described it this way, like more words helps. When females go from liberal to conservative, there's 18% vegetarian females, liberal, and then it goes to 0, which is a bigger drop. That's a larger difference right there. Versus males are like 7% vegetarian for liberal, and that drops to 0 also. Female liberal have maybe 5%. We're looking over here where this bar would be right about there, about half of 10%. 5% female liberals are carnivore compared to about 10% male liberals are carnivores. No, right, Cameron? And then over here, that's about 12%, which is a 7% difference for females, versus males jump all the way to 38%, which is like a 28% difference. So they're talking about the difference between the bars, and really a lot to compare right there because it's 3 variables. Not my favorite question. Let's go more in depth on mosaic plots and associations over here. So we'll finish off office hours. Really good office hours. Did everyone get 100? If you were here right now, did you get 100 on this? So Stat 201, more in depth on associations. And then I have videos for a lot of the other quizzes, but let's go do it over here. Okay, let's get jump going. Do I have jump installed? No, we don't have jump installed. Oh my gosh. So, do I have R installed? Well, this needs to be done before class, right? 2-factor authenticate. How's everyone doing this morning? I hope you all got some hundreds. I'm installing this on a UT-owned computer. We get some hundreds. SAS. I'm downloading Jump Pro for Windows. Hope a lot of students download this software. Oh, downloading really quick. So many MuBucks given out. Big semester ahead, lots of work. Start early, get the homework done during office hours. Great time to get it done. We're gonna try to get some office hours up. We're getting Jump installed. Was it, I think it was still here who asked about associations. Where'd the files go? Jump. We are copying the Jump files. I'm doing the Jump install. We're almost there. 24 cores, how fast can it install? Remember back in the day, installing things took maybe an hour sometimes. And we just had disks, floppy disks. You'd insert the floppy disks, go between them, just insert more floppy disks. Loading up. Let me throw some points. Who's still here? We got just a little bit before class. 11:20. Me, William. Let's throw you 100 points, William. MeBot only sees you if you're talking. It's, oh wait. Here we go. Lunchtime. Yes, I should grab, put a thing in here with like drinks instead of. Reagan, you asked about it. We've almost got Jump installed, Reagan. So Jump will be on here in a second. And this will be good examples for class. Okay. It is installing. Almost there. Sort of the main screen. Let's do it. Okay, we're over here. Just nice background. Good stuff. Jump is installed. Finish. Great desktop shortcut. Here we go. Jump has been installed. Wait to register as I tell all my students. Never register. Sorry, Jump. And then go here, new data table, and we have Jump. Here we go. Okay, so you wanted to know about associations. So an association is when knowing X tells you something about Y. Now, it's not a correlation. We wouldn't say that's a correlation. Correlation is a specific type of association, but an association is when knowing X tells you something about Y. So let's pretend right here that we have a data variable, something like, let's say attend class. I always use this example. And I don't know if I missed anything, but Dana likes to be graded. They should be graded in about a week. So, and here we go. I think they were due on Friday, were they? So we're gonna go here and write yes, no, yes, no, and yes, yes, no, no. Now watch these numbers. We have the people who passed the class, 200, 200. Now let's go here, 50, 50. Now let's look at the data. Analyze, fit Y by X. And I want to show you why attending class and passing a class right here, if this was your class, would have no association. We're going to put this nice side by side on the screen. You'll see it here in half a second. Where's that other Jump window? Really? There it is. Okay. So take a look at this data right here. Notice that the people who attend class, 20% of them did not pass, versus the people who did not attend class, 20% of them did not pass. Does that make sense, Reagan? So right here, look at what's going on. We have 20% of the attend class did not pass, and that would be this group right here. Did you attend class? Everyone here attended class, and then 20% did not pass, 80% passed. These are the counts of the observations, also seen down here in the contingency table, showing us the counts of the observations. But how are you doing with this concept right here, Reagan? Does it make sense that we are looking at 20% of the people who attended class did not pass, 20% of the people who did not attend class did not pass. And this would be signs of no association. This is signs of no association because the conditional distributions are equal to the marginal or there's no difference between them. Now notice, as I start to change the numbers right here, we'll make it, yeah, it should go like that. You'll notice that there's a bigger gap between the conditionals. So now we would say there's probably a moderate association, or maybe we could say small or moderate, because at what point is it small, moderate, like that's weak right there. This is a little bit stronger, and we're making it even stronger. The bigger this gap right here is, this gap between them, the bigger that gap is, the stronger the association. To where if you saw data that looked something like this right here, look at this huge gap. Because now almost 75%, not quite, but nearish, notice how that's over there on the margin, but that's not the marginal, that's the marginal over here. Around 73% were to do the numbers of people who did not attend class, did not pass, versus over here, 13%. And you could find these numbers by using the table, and JMP has these really nice features where you can kind of hover over things. But now this is a very strong association. So when is an association stronger? The bigger the gaps. And I wonder if it'll auto-update this. If we change this to 20, oh, it is. I think it is auto-updating it. So notice here the numbers update and look at how different the percentages are. Maybe we need to move this back on top of it here. But the bigger the differences in the percentages, then the bigger the association. Like those are not that big in difference. These are identical, so that's no association. This is like a weak association. This is a good bit stronger of association. That's even stronger. So the bigger the gap between these percentages, and I'm showing the percentage at all times, because that's 60% of the people who did not attend did not pass, whereas 28.57%. So if there's no association, does that mean the two are? Yes. Independent means knowing one thing does not tell you anything about the other. So if I say, let's say I flip a coin, the next coin flip would be dependent or independent of the previous one. So when I flip a coin, would the next coin flip be independent or dependent on the previous one? The next coin flip. I flip it again. I say, oh, that one got heads. Let's flip it again. The next coin flip would be what? Would it be independent or dependent? So independent means it doesn't tell you anything. Dependent means it does. It would be independent because it doesn't tell anything. Now tell me about this. Would somebody passing the class be dependent on them attending the class? Now you're not saying you know they'll pass, but somebody passing the class, is it independent of attending or dependent of attending? Is somebody passing the class independent of attending or dependent on attending? Somebody passing the class. It'd be dependent, which means associated. So when we say it's dependent, then there's some sort of association like, yeah, if you attend class, you are more likely to pass, versus if you do not attend class, you are more likely to fail. So there is a dependency or an association right there. And the bigger the association, the bigger the differences in the conditional distributions, excuse me. Dhruv, good to see you here too. Let's show you some points and let's make you a mod. Does that help right there, Regan, with these concepts with mosaic plots? When you look at the conditional distributions, the bigger the gaps in the conditional distributions, like the bigger the difference or mathematically, like the percentage differences, because that's the difference in the gaps, the bigger the mathematical or visual gaps there is in conditional distributions, the stronger the association. When the difference is a zero difference, the mosaic plot will be perfectly horizontal across. And when it's perfectly horizontal across, there is absolutely no association. Like that is no association. And this one right here is like a pretty much non-existent. Does that make sense why there's pretty much no association here? I would say there's pretty much no association because the conditional distributions are virtually identical. And you can see it right here by there being no gap. This is 13% right here, and this is 13.8. So there's virtually no association. We can't say perfectly no, because that's only when they're perfectly even like this. But virtually no, because if they're like this, we could say we don't really see any association. Virtually no. Well, that's got it. We're going to head out here. I think we've got the outros. Let's check it out, and we'll be back here in just a few minutes. Bye!
Hey Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No!